Welcome to the Math Worker. Today we'll be covering the CCML Algebra 1 Contest 2 2016-2017 Division A. Okay, question 1. Evaluate 3.7 minus 5.6. Well, you could just do this the opposite way around, so you just have 5.6 minus 3.7, which gets you like 1.9, and you just put a negative in front of it. And that gets you the answer, so the answer is just negative 1.9. Just basically that simple. You could do it the normal way too, but if you want to keep track of the positive, it works either way. Solve for 2. Solve for h. 3 plus 7h is equal to 1 plus 4h. So minus 3 to the other side, so you get, and you minus 4h, so you get 3h is equal to negative 2. So h is equal to negative 2/3. Okay, so the answer is just negative 2/3. Just that simple. Basic variable question. Express 1.013 repeating as a common fraction. So let's set x equal to 1.013 repeating, right? So set as a variable. And then what you want to do is that you want to get like 13 again into this. So technically, you want to multiply it by 1, 2, 3. So then the decimal is right here. 1, 2. You might want to just multiply by 100. So you get 101.3, and then 1, 3 is repeating, basically. So something like this. So then when you subtract them together, you get 99x, and 101 minus 100 minus 1 is 100, and 3 minus the 0 is 3, and then the 1, 3 repeating minus the 1, 3 repeating just becomes like 0, so it just leaves like this. So x is equal to 100, and 103 divided by 99. So basically now we have to get this into a common fraction. This is in decimal form, so you want to subtract the decimal out basically. So how we take out the decimal, that's 100. You could write this as 103 over 10 over 99. Okay, let's move this away. We already got some portion of it. Okay, now we can have this is equal to basically 1003 over 10 times 99. So this is just basically the same as 2 times 5 times 3 squared times 11. So this is obviously not divisible by 2 or 5, so we don't have to check those. Is it divisible by 3? That's 9. Nope, that's 9, 1, 13. So it's not divisible by 3, so it's not divisible by any either. So is it divisible by 11? 11, that makes 99, so that's 113. So no, that is not divisible by any of these numbers. So it's just 1003 divided by 990. So that's the answer. Okay. So to solve like a repeating decimal, which is what I refer to number 3 as, you basically set the variable as a decimal, and then you try to like multiply it by some amount, like by a 10 power, like by a power of 10, like by 10, 100, 1,000, 10,000, 100,000, basically, etc. So you could get it. So you subtract those repeating decimals away. Question 4. Evaluate 3 minus 5 over 2 divided by 3 over 5. Write your answer as a common fraction. So using Euler operations is 3 minus 5 divided by 2 divided by 3 or 4, which is the same thing as multiplying by 4 over 3. So the 2 cancels with this one to make 2, so that's equal to, this portion is basically the same thing as saying 10 over 3. So you have 3 minus 10 over 3. That is 9 over 3. So technically this is just 9 over 3. Minus 10 over 3 is negative 1/3. So that's your answer, negative 1/3. Pretty simple. Question 5. A square's length is increased by m%, and its width is increased by m plus 20%. By what percent has its perimeter has been increased? So a square's length is increased by 10%, right? So the perimeter, so we just have to look for like the percentage basically increase. So we have a square, let's say it's x, right? So we have x, so the perimeter is 4x. So the length is increased by m%. So it's right at 1 plus 1 plus. So if this was like 20, right? You divide it by basically 100. So 1 divided by 100 times x times 2, basically, because it's the length, so it's on both sides. So it's like this this length, and now we just have to look for these for like the width. And the width is increased by m plus 20%. So this one is added by 2 times 1 plus m plus 20 divided by 100 x, right? So now you get what is this? 100 plus m. So you get 200 plus 2m over 100 x plus 100 plus m 2m. Okay. And you have this one, which is 100. So that's m plus 120. So that's 240 plus 2m over 100 is equal over x, or times x. So let's move this up. We need a little bit more room. Okay, so adding them together, we get 440 plus 4m over 100 of x. Sorry, x is on the other side. And the original was 4x, remember that, right? So basically, we have 440 plus 4x over 100. So basically, what percent has its perimeter has increased? So we just have to have this number divided by 4, basically. So this is divided by 4, so you don't really, this number 440 plus 4x over 100 times x divided by 4x. So divide by 4x, you just put the 4 on the bottom, right? So you divide the 4 from here, so that gets 110, and this gets just 1, so it's equal to 110 plus m over 100. So this would get you to, and you had to minus 1, because it's going to be in percent, because think about it, if it's like, let's say it was like 1.25x, and then this is not the number, but then you have like x as the original, right? And you divide by each other is 1.25, but increased by 25%, so you just had to subtract 1 out. So subtracting 1 out from here, you minus basically 100 from the top and the bottom. So it's just minus 1. So that's 100 over 100, so you minus that, so you just get 10 plus m over 100. So that's basically your new amount. So it's you just have to focus on the top part, because that's the percentage we're looking for. So this is what we're gonna be looking for, because it's gonna be out of 100. So your answer is 10 plus m%. But you don't have to write the percent sign, because it already tells you like what percent. So the answer is just 10 plus m. So it's really just that easy. Okay. Question 6. Solve for m subscript 1, where f is equal to g times m1 m2 over r squared. So write your answer as a single fraction. So f times r squared is equal to g m1 m2. So f r squared divided by g and divided by m2 is equal to m1. So this is your answer, fr squared over gm second. So basically that's simple. Just rewriting your variables. Question 7. What is the units digit of 2017 raised to a power of, what is that? 43,200, wait, 4,321 times 1,234. So Basically, you're just gonna be counting every single 4 multiple in this number. So by looking at this, what's the units digit? We're just gonna have to, because if you think about the units digit, let's just say x raised to a power of some kind of exponent, right? So if we have, let's say 3 raised to a power of 1 is just 3. I mean, actually, let's use 7 because the unit digit here is 7. 7 raised to a power of 1 is 7. 7 raised to a power of 2 is 49, which the unit is 9. So 7 raised to the power of 3 is 343. So it's going to end at 3. And 7 raised to the power of 4, if you think about it, it's just 49 times 49. And 9 times 9 is 81, right? So it's just going to end at 1. So then if you have 7 raised to a power of 5 and this ends at 1, if you multiply at 7, wouldn't the units digit just be 7? So it kind of just repeats to 9, and then 7 to the 7 is equal to 6. I mean to 3. So 7, 9, 3, 1. So it repeats every single 4. So the units digit repeats every single 4 at a pattern of 7, 9, 3, and 1. So basically, we just had to find whatever the exponent is and divide it by 4. So we have 4,321 times 1, 2, 3, 4 divided by 4, basically. So based on this number, we just have to divide some of these numbers out. So let's say we divide this number. So this is 6. Let's get 617 divided by 2 makes 2 here. So what this tells me is that this is somehow going to be odd. So it's not going to be like even multiples. So remember the pattern was 7, 9, 3, and 1. It's not going to be even. So this is not going to be even overall. So if it's even, it's either going to be 9 or 1. But since it's odd, it's either 7 or 3, basically. So we just need to find out what is the remainder, basically. So how would this work? So it will equal to basically a 4x plus some kind of remainder. So 4,321 times 1, 2, 3, 4 minus the remainder divided by 4. So basically you want x to be an integer, and remainder is only 0, 1, 2, or 3. So that equals x. So as I said before, that's 4,321 divided times 7,046 divided by 2 minus r over 4 is equal to x. So basically, if this is an odd, it's gonna have something over. It's gonna be some kind of number, and then over 1 over 2, basically. So some kind of mixed number and 1 over. So r has to be equal to 2. Because if r is equal to 2, there's got to be 1/2, and you subtract that 1/2, and you get x. So basically, r has to be equal to 2, so the remainder is 2. So if the remainder is 2, right, we just have to look for the second number. Oh, sorry, it's not, ignore the part about the even part. So basically, it's, what was the number? 7, 9, 3, and 1. So since it's the second one, the answer is 9. So that's how you do it. Takes a little bit of logic. Okay. Number 8. In a standard deck of 52 cards, the kings, the queens, the jacks are commonly referred to as face cards. When drawing one card from a standard deck, what's the probability of drawing a heart or a face card? So when drawing one card from a standard deck, what's the probability of drawing a heart? So in a deck of 52 cards, there is diamonds, clubs, hearts, and spades. So all 4 of them are even amounts. So 52 divided by 4 is 13. So you have 13 hearts. I can't really draw a heart that well. Okay, 13 hearts, right? Or a face card. Face cards, they said in the beginning right here, kings, queens, and jacks. So technically, there is a king, a queen, and a jack in each of the heart, diamonds, spades, and clubs. So that's 4 times 3. That makes 12. But some of those face cards, kings, queens, jacks, are also heart, so we gotta subtract them together. So there's only 3 of them. There's only a king of heart, queen of heart, and jack of heart, so you might need 3. So 13 plus 12 minus 3, that makes 22. So what's the probability? Yeah, 22 out of 52, which simplifies it to 11 over 26. So that's your answer, 11 over 26. Okay. Question 9. What is the first non-zero digit to the left of the decimal point of first non-zero digit to the left of the decimal point of 12 to the 6 times 5 to the 12? Okay, so 12 to the 6 times 5 to the 12. Okay, since this can make tens basically, because if it's 5 times 2, it's gonna make 110. So if it's like, think about it, 5 times 2 is 10, right? And then 5 squared times 2 squared is 100. So it makes 2 zeros. So imagine you have a 3 in front of it, and 3, that makes 30, that makes 300. So you see how that works? The first non-zero digit to the left, so that would be 3, 3. So you just look at these digits, right? So you just take away take away all the tens. So we have this thing factors out to 2 to 2 times 3 power 6 times 5 to the 12, right? So that's 4, that's 12, right? So that's 2 to the 12 times 3 to the 6 times 5 to the 12. So taking away all the tens, that's 5. 5 times 2 is 10, and there's 12 of them each, so there's 12 zeros. And then the first number is just 3 to 6. So 3 to 6 is that's 9 to 3, so that's 9, and that's 81, so that's 343. So the first digit is 3, because you gotta look at the units, basically, because there's just a bunch of zeros afterwards. Like, there's 12 zeros afterwards. So the first answer, so for 9, the first answer, wait, 980, oh, oops. Sorry, it's not, it's 729. The answer is 9. Sorry, I multiplied wrong in my head. Because it's 3 squared is just 9 to the 3, because, 3 to squared to the power of 3 is just 3 to the 6. So that's 9 to the power of 3. And 9 times to the power of 3 is just 9 times 9 is 81, times another 9 is 729. So the units digit is 9. I mean, the units digit is 9, so it's gonna just be like 729 and then like 12 more zeros, basically. Okay, so the answer is 9. Question 10. What's the largest 5-digit odd number that's divisible by 11? So, it's a 5-digit number, so we have, let's say, x. No, I'll just make placeholders. So 1, 2, 3, 4, 4, 5, right? So, the rule for 11 is that each number, basically the first number plus the third number plus the fifth number, plus these numbers, right? And then you minus the second, and then you minus the third. I mean minus the fourth. The remainder has to be a multiple 11. So it's either like negative 11, 0, 11, etc. basically. So what's the largest 5-digit number that is divisible by 11? So that's the rule basically for it. So let's just have something like the highest 5-digit number is 9999, right? So then that's so you have a remaining 9 left over, because 9 plus 9 plus 9 minus 9 minus 9 is 9, and 9 is now a remainder of 11. So basically we gotta have this number turn into a like a multiple of 11. So a way to do this would be, actually, let's do it a different way. Let's not worry about the rule. Let's just say we have 11 multiple, and we'll kind of call it 11x, right? And it has to be less than or equal to 99999, right? Because it's either greater than or equal to it. If 99,999 is a multiple of 11, then it works. So we have 11 divided by that number. So divided, that's 99. So let's write that out. 99999. Have 11, so you have 9. So that's 99. Let's move this a little up. Okay. So you minus the 99. No. minus the 99, you get a 0, and then you drop down the 9. So this is 0, and then you have 99, basically. 0, and then you have 99 again, so you put another 9, so that's 99, subtract, and then you drop down the other 0, which is also 0. So you have 90, 90, 90, 90. So you have 90, 90 times 11, basically. So you have to find the the first odd digit. So since it has to be odd, right? Even 999 9090 is even, so even times the odd is even, and it asks for odd, we gotta go a little less than that. So we gotta have to go 89 times 11. Okay, so that's what we have, 89 times 11. Okay, so we have 89 times 11. So that's get 9089090809, right? Add them together, you get 9, 7, 17. That adds 1. That's 9, 9, and 9. So your answer is 99,979. Okay. Number 11. Mike wants to mark down his prices to 40% off. There's already a sale of 20% off on all items. What percent discount needs to be applied to the sale price to achieve an overall markdown of 44 price? So imagine you have the original price is X, right? So the sales price is 0.8x, right? But overall you want 0.6x because that's a 40% markdown. So what number times so you need another percent markdown. So some kind of number times so let's say you want a 20% markdown, right? That's just 1 minus 0.2 times the 0.8 as the sale. So technically whatever you put as your what percent markdown should be made. So we just have 1 minus y times 0.8 has to equal 0.6. So 0.6 divided by 0.8, that is 0.75 is 1 minus 4. Because you just think about it. So 0.6 divided by 0.8, you can take out the zeros and you put 6 over 8. That turns out to 3 over 4, and 3 over 4 is just 0.75. Okay. So then you have 1 minus 0.75, you get 0.25 is equal to y. So y has equal 25%. So your answer is just 25%. Or you can write in decimal point, which is 0.25. But since they ask for percent, just write 25% just to be safe. Number 12, A is equal to 1100 base 2, and B is 1000 base 2. In base 2, what is the least common multiple of A and B? So let's convert them to base 10 first. So, sorry. So 1100 base 10 is 0 plus 2 times 0 plus 2 squared times 1 plus 2 cubed times 1. So you get 4, and that's 8. So 4 plus 8 is 12. So A is 12. B in base 2, that's 0 plus 2 times 0 is 0 plus 2 squared times 0 is 0. And 2 cubed times 1 is just 8. So overall, B is just 8. And what is the least common multiple of 12 and 8? The least common multiple is 24, right? Because this is 2 squared times 3, and this is 2 to the cube. So yeah, 2 to the 3 times 3, which is just 8. So 24. So 2 to 3 is 8 times 3 is 24. So your LCM is 24. And we need to put 24 in base 2. Because that's what it said in base 2. So 24 in base 2. So think about like base 2. So so 2 to 1 is 2. 2 to 2 is 4. 2 to 3 is 8. And 2 to 4 is 16. And that's the highest amount because 2 to 5 is 32, which goes over 24. So we have 2 to 4, right? So we have basically 5 numbers. So 1, 2, 3, 4, 5. So we have 5 numbers, and the first number is 1. Because, so this is going to be 2 to the 4 power. So that would make 16. So minus the 16, you have 8 left over. so you need 8. So you need 2 to the 3, so you have 1 here. So everything else is, so you minus the 8 is 0. So basically, you put 0, 0, 0. So it's just 11,000 base 2. So that's your answer. 11,000. Remember to put the base 2. Okay. Number 13. The odds of an event not occurring are 3 to 4. What is the probability that an event occurs? I mean, the odds of an event not occurring are 3 to 4. So what is the probability that the event occurs? The event occurs because of, oh, so the odds of it occurring to not occurring is 3 to 4. So if it's 3 to 4, right? Then the overall probability is out of 7, because 3 plus 4 is 7. And the probability that it occurs is 4. So the answer is just 4 or 7. Okay, basically that simple. It might take you a little time just to reread it, because it's kind of a little strange, I guess. Number 14. The sum of 4 consecutive integers is 8 times the smallest odd integer. 4 consecutive odd integers, okay, is 8 times more than the smallest odd integer. What's the largest of the 4 odd integers, okay? So you have, let's say the smallest is x, right? So then the sum of it is, the next odd is x plus 2, the next odd is x plus 4, and the next odd is x plus 6. And this sum is 8 times the smallest, so it's equal to 8 times x. So that's what you have. So putting that together, that's 4x. 2 plus 4 plus 10 plus 6 is 12. Is equal to 8x. So 12 is equal to 4x, and x is equal to 3. So what is the largest of the 4? You have to add 6 to it, so you add 6. So the largest is 9. Basically, that's simple. Okay, number 15. An ant is traveling from A to D along the path shown in the diagram. The ant travels in a rightward direction with 2 conditions. One is traveling along route. If traveling along route 1, the ant cannot use routes 8. Cannot use route 8. And 2, if it's traveling around route 3, it cannot use route 5. How many different routes are possible? Okay, so it's traveling at, let's say it's route 1, right? It goes to 1, then it goes to B, basically, using 1. It cannot use route 8, so you could either use 1 or 6, so you could multiply by 2. So you have 2. And then it cannot use route 8, so you could have 3, and then 7. I mean 5 and then 7, or 5 to 9, and then 6 to 7, or 6 to 9, but you can't use 8, right? So basically, you just multiply that by 2. So 1 has 4 possibilities. If you're using 2, basically, you could use anything because it said nothing about using root 2. So you have 2 here and then 3 here. So yeah, 2 times 3 is 6. If you're using root 3, right, it says right here, if you're using root 3, you cannot use root 5. So you only have one possibility. If you use 3, you have to use 6. And there's only, and you could use 7, 8, or 9. So it's 1 times 3 is 3. And 4. If 4, there's no condition, so you could use 2 here and 3 here. So 2 times 3 is 6. So the total is 4 plus 6, which is 10, plus 3 is 13, plus 6 is 19. So the total amount of routes it could go through is 19. So you just break it down into parts and then solve it individually. 16. Scott's favorite number has the following properties. When divided by 5, 6, or 8, the remainder is 4. And 2, his number is greater than 5. What is the smallest possible natural number that could be Scott's favorite number? So let's think about it. Let's say his favorite number is x, right? So if it's divided by 5, it's remainder 4. If it's divided by 6, it's remainder 4. And when it's divided by 8, it's remainder 4. So let's say we have 5, A. A is some kind of constant, plus 4. X is equal to 6A, 6B, plus, like, 4. And X is equal to 8C plus 4. Because right now, A, B, and C are constants, right? So it's some kind of, like, some kind of natural number. So if it's like 2, then it's 10 is 14, right? And A, B, and C do not have to be the same. So basically, I need to say that both of these numbers have to be the same. So it's 5A, 6B is equal to 8C. So what this tells me is that basically I need to find a least common multiple of 5, 6, and 8. And then I could just add that number by 4. So 5, 6 is 3 times 2, and 8 is just 2 to the 3. So I need 2 to the 3 times 3, times 3 times 5. So that is, that makes 10, that's 8, that's 24, so that's 2,000, wait, that's 2, 4, oops, sorry. That's 2, 4, that's 2 times 2 is 10, so let's just get that out already. So that already makes the 10. And that's 4 times 3 is 120. I mean 12, so times the 10 is 120. So 2 cubed times 3 times 5 is 120, and add the 4 is 124. So if 124 is divided by 5, it makes the 120 gives the integer with the 4 remainder. And then 6 divided by 120 gets that integer and 4 remainder. And 8 divided by 124 gets the 120 gets that integer and then gets the 4 remainder. So the least common is smallest possible natural number is 124. So when you see a question like this, basically look for the LCM and then add the remainder. Question 17. In the pattern shown on the right, how many dots are in the 20th figure? So basically, let's kind of just do like a mathematical purpose right here. So right here, you have 1, right? When you have figure 1, you have 1. When you have figure 2, you have 3. When you have figure 3, you have 9. So if you have figure 4, right, it's like 1 and then 1, and then you add 2 of them, and you add another one here, right? And then the fourth one, you just add another one. And I guess you had to add it like right here, basically. So you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. What is the pattern here? Is there any more figures? Is that all the figures? So that's 1, that's 3, oh, sorry, that's not 9, that's 6. Oops. 6, right? And then you have 1, 2, 3, 1, 2. Okay, and you have 1 here. So I guess you add 1 here and add 1 here. And then basically from that, you add 1, 1 here. So you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So you have 10. That's the fourth one. So based on this pattern, you have a difference of 2, difference of 3, difference of 4, then a difference of 1, and then difference of 1. So this is telling me that since if the first difference is the same, then it's gotta be linear. If it's the second difference is the same, it's a quadratic. So this is a quadratic model. That's what it's telling me. So I just need to make a quadratic model based on this. So since the second digit for the quadratic is 1, it's kind of telling me that the quadratic in the first in what it's telling me is that the coefficient for the quadratic coefficient is 1/2. So I put 1/2, and then I could just put x squared, right? So I know the there's not gonna be like some kind of c, right? I don't know what the coefficient x is. I'm just putting this placeholder. I know there's no c because basically if you have a figure 0, it would just have 0, right? So when you put 1, it's so you have x right here. When you put 1, it's 1. So that's 1/2. So you got a minus a half. So this is gonna be the model. So does it make sense? That's 4 minus 2 is 2 over 2. 2 is that's 4 minus 2, which is 2 over 1. So that makes sense. Oh, sorry. It has to get 1, so that's plus 1/2. So that's 4 plus 2. That's 6. That's 3. So that's 9 plus 3, which is 12 over 2 is 6. And that's 16 plus 4, 20. Yeah. So this is the model 1/2 x 1 half x squared plus 1 half x. So if you want to find the 20th, just plug in x is equal to 20. So that's 400 plus another 20. So that's 420 over 2. So the answer is 210. Basically that simple. Question 18. So let me move this a little bit over. What is the sum of the positive divisors of 1001? Okay, so 1001. What could this be divided into? 2 does not work because it's not even. 3, it doesn't add, the digits don't add up to 3, so it doesn't work. So 5, nope, because it has to be 0 or 5 in the end. 7, if we put in 7, that's times 1, that's 30, so that's 4, that's 28, and that's 21. Okay, so that works. So that's 7, 30, 28, 21. Yeah, so 143. 143 could be factored out to 11 and 13. Yeah, so that works. So 1001 is just 7 times 11 times 13. So 7 times 11 times 13. So the factors is 1000 over 1, and then 7, and then if we put 7, which is the next smallest, is 11 times 13, which is 143. So 7 times 143 is 101. So we're just putting this in pairs. If we put 11, it's going to be 7 times 13, which is just 91. If you put 13, it's just going to be 7 times 11, which is just 77. And then I think that's it. Yeah, that's basically it. So add them together, we got 1002. That's 150. That's 102, and that's 7, 8, and 90. Right. So adding them together, that's 1152, and that is 192. Let's move this a little bit over. So that adds up to 4, 4, so 1344. So that's your answer, 1344. Okay. So just make a factor tree and just like figure that out in pairs and then add them together. How do you know that there is like 8 amounts? Basically, when you factor it out, which is 1001 to make 7 times 11 times 13, you just add 1 to every single exponent. So that's 1, that's 1, that's 1. So add 1 to 1 is 2, add 1 to 1 is 2, and add 1 to 1 is 2. And you multiply them all together is 8. So there should be 8 positive factors. That's what it's telling me. So that's how I know I didn't miss one of them. Okay, number 19. The greatest common factor of two distinct perfect squares is 15. If, wait, the greatest common factor of two distinct perfect squares is 25. If the product of the two numbers is 122,500, what's the smallest positive difference of the two numbers? So, the greatest common factor, if the product of the greatest common factor of two perfect numbers is 25. So, what it tells me is that it's basically 25 of two distinct perfect squares is 25. So it's going to be 25 times like some number squared, sometimes number squared, basically. And then you have another number which is just 25 times like times like z squared times w squared. Because 25 is going to be GCF, so it's got to be the greatest common factor between them. So basically, when you multiply these together, you're gonna have 25 times 25 times x squared times y squared z squared, etc. Maybe there's even like more, like I don't know, maybe. So we just know that based on when you multiply the product is 122,500. So basically, from that number, I just need to divide by 25 twice, and then I'm gonna have whatever remaining, and those should be in perfect squares. So what's the smallest possible difference of the two numbers? So 125 divided by 25. So I put 4. That makes 100 minus. So that's 225. And then you put 9. I think that's 100. That's 200. Yeah. So you put 9. and that's 225, and then you just put 2 more zeros, basically. So this number 122,500 divided by 25 is 4,900. Okay, so that's what we have already. So 4,900, and then divide that by 25, because it's like 25 times like those coefficients for the first number times 25 times the other coefficients for the other numbers. So divide by 25 here, we have 1, that's minus 25. You get 24 and 0. So you put 9 here again. So that's 100, 200, and 225, basically. So minus that, yeah, 15 and 0. So that's 6. Right? So you have 196, basically, as the product of the product of the two numbers of the two distinct squares. So 199. That's not the answer. I just squared it just to make sure you know what it is. So 196. Basically, let's factor that out. That's 2. That's 98. 2 again. That's 49. And that's 7 and 7. So the only perfect squares in here is just 2 squared and 7 squared, right? So those are the only well, basically if we had to use pairs for perfect squares, because it's got to be two perfect square multiplied by each other, we have 2 squared times 7 squared. That means there's 3 times 3. So there's 9 multiples there's 9 factors. So let's put that together. So you have 196, 2, and that's 7 squared times that is 98. You can't have 3, you have 4, which is 49. And then you have 49, and then you have 7, so that's 28. Yeah, 140 times 56. Yep. So, and then you can have 2, 3. So, and then you can have 14 times 14. So 14 is required twice. Sorry, 14 times and 14. 14 and 14 are not perfect squares. 7 and 20 are not perfect squares. 4 and 49 are perfect squares. 2 and 29 are not perfect squares. And 1 and 96 are perfect squares, because this is 1 and this is 14 squared, basically. So the smallest positive difference between the two numbers, this one is 195. 196 minus 195. 49 times 4 is 45. So this is obviously the smaller one. I mean, it's just a smaller one. So it's 4 and 49 of the positive of the two numbers. So because they said both of the numbers are perfect squares, right? So you have 4 and 49, and then it's times 25 from both sides. So then when you multiply these two numbers, you get 122,500, right? And these are the two perfect squares. So you have 100, and you have what's 49 times 25? Let's do that out. So that's 45. That's 4. So that's 245. Put a 245, and then put a 0, and then that's 18. That's 1. That's 8, and that's 9. So you get 5, 2, 10, 12. So 1,225, and this is 100. So subtracting them together, 1,225 minus 100 is 1,125. So that's your answer, 1,125. Okay, that took a lot of work. But basically that's the answer. It's just tedious, not really that hard. Question 20. How many distinct rectangles can be formed by tracing the lines in the figure above? Okay, this is actually kind of simple. There is a really neat trick to this. So basically, think about like the lines vertically and then horizontally, or horizontally and then vertically. I'm gonna think of it vertically and horizontally. So when you want to make a rectangle, you basically just need to choose 2 lines, right? So you have 1, 2, 3, 4, 5, 6. So you have 6 of them, and you want to choose 2, basically. So if you choose this line and this line, and then this line and this line and this line, this line, this line, this line, basically. And then you can have 1, 2, 3, 4, 4 horizontal lines. So you just have, of the 4, you just also choose 2, because you need like 2 of these and then 2 of this. And then those, so basically, let's say So what this does is like, let's say you choose this line and this line, and you choose this line and this line. Basically, this line, this line, and this line, and this line kind of makes that rectangle. So that's what it does. So you basically just have to use like it's basically using combinations to make your rectangles. So that's a really easy way to think about it. So it's just 6 factorial over 2 factorial, 4 factorial. So that makes 6 times 5 divided by 2, so that's 3 times 5, so that's 15. 4 factorial over 2 factorial, 2 factorial. So that's 4 times 3 divided by 2, so this 2 times 3 is 6. So then you have 15 ways to choose from vertically and 6 ways to choose horizontally, and then 15 times 6 to make those rectangles would be 90. So the answer is just 90. Pretty cool way of solving it, instead of like counting every single one, which takes forever. So that's your answer, number 90. Well, that basically completes everything for the CCML Algebra 1 Contest 2. No, Calculator 2016-2017 Division A. Thanks for watching, and I'll see you at the next math record.